So let's start with the problem number 3.39. So this problem states that a waves splits a sheet of 20 degrees Celsius water. So water is flowing through this pipe or sheet, and a waves is splitting that sheet, right? As shown in figure 3.39. This is the 3.39. Both waves and the sheet are very long into the paper. Now, if the force required to hold this sheet stationary is F equals to 126 Newton. You see, the force that is required is 126 Newton. Since the flow is this direction, so you need to place the force in this opposite direction. Per meter of depth into the paper, it says that what is the angle theta of this waves. So we need to calculate this theta, right? So it's pretty simple actually. You see that the water is flowing in this direction, and if we consider that the water flow is in steady state condition, that means whatever flow is going through this position, it should be the same as this position, right? Now, if we want to calculate mass flow per unit depth, right? So what would be the mass flow per unit depth? M divided by B equals to rho VH, right? So that's the equation. Now we know for water, it's rho is 998 kg per meter cube, and V is 6 meter per second. You see the flow rate, velocity is 6 meter per second, and the H is 0.04. So H is basically this, diameter, H. So the calculation gives 239.5 kilogram per second meter. Now, if we want to, if we consider this is a control volume, right? Control volume. So surrounding this is, now we can have or apply the momentum integral relations, right? And the momentum integral relation will be summation of fx equals to minus f. Whatever force you are applying in this direction will be, summation of all of these forces will be negative value of a, because they are in opposite direction. So summation of fx equals to minus f equals to, so summation of fx of what? M, you see the mass flow rate into the velocity, out velocity, minus mass flow rate into inlet velocity, right? So the mass flow rate multiplied by, see the outlet velocity and inlet velocity, that's what you need to calculate. Now, because the velocity is a vector, so we need to calculate in one particular direction. So if we consider that the inlet direction is this one, right? Then the outlet direction V out or U out should be V multiplied by cos theta by 2, because you see this is the inlet direction of velocity, U in, right? So that this angle will be half of this total theta. So that's why we write this is the V, right, out. So it should be V velocity value multiplied by cos theta by 2 minus V U in equals to V. U in means V, right? So we can calculate equals to M. If we take the common V, so it gets cos theta by 2 minus 1. Now we know the minus F value equals to 124 Newton per meter equals to M, we already calculated from here, 239.5 kg per second meter multiplied by velocity is 6 meter per second, then multiplied by cos theta by 2 minus 1. Now, if we solve this equation, we should get the cos theta by 2 equals to this, and theta by 2, then theta equals to 48 degrees. So this theta value is 48 degrees. That's the answer.